Welcome to another Java tutorial. Now that you're getting used to the interface and the IDE, it's about time to go over some things that you should know from before. And in case you haven't noticed, the class that you create must have the same file name with a .java extension. This is just a Java standard, so you'll just have to conform with that. And we've been using package. Packages are used to control namespaces. So if we were to look back at our old examples, let's look at figure 3.4 and figure 3.7. They are both using gradebook class in the text. If you wanted to just use class gradebook, you would have to create a new package for those figures. So you would create a package for figure 3.7, 3.8, and you would create a package for figure 3.4, 3.5. And then you can use the gradebook class. However, I want to keep chapter 3 all in one package, and that's why I've chosen to use figures as the class name rather than the actual class name. Okay, so let's look at the new figure. We are creating a class account. So this is for a bank balance. It looks like it's a savings account or a checking account. So we have a constructor. We have a private variable called balance, and it's private, which means anything outside of this class is not allowed to access it. Only this class can access balance, and we access it here, here, and here. We have a constructor that takes an initial balance as a parameter. And this constructor does some checking. It makes sure that you're initializing it with some positive deposit. Really, this should be greater than or equal to 0, because if you have a negative deposit, which means a withdrawal, it wouldn't allow you to initialize it, and it would default to 0. Any integer or float values will default to 0 if you don't initialize it or don't have a constructor. If you have a private string and you don't initialize it, it will default to null. One thing to note is null is different from a blank string. Ignore the error. If I had a blank string like this, it would just print nothing. Null means something different. It means that it's not pointing to any kind of string, and that's why it would print out null, which is what you saw in previous examples. Okay, so if it's negative, it will leave the balance 0. If it's positive, it will initialize the balance. We have two more routines: credit, which adds to the balance, and get balance, which returns the balance. It's important that we choose double here because balances are stored as dollar amounts, and we might deposit something with cents in it. So that's why we need a double, which is a floating point value. If you have integers, you'll lose all your cents. And notice the getter. We don't have a setter because we always add to the balance. You can't just set the balance. Notice the getter has a get prefix, so get balance. And if we had a setter, it would be called set balance. These are not a requirement of Java. You can call it whatever you like. You could call it balance to get a balance. You can also call it balance to set a balance. Okay, so to do getters and setters, it's perfectly okay to do this. It's called method overloading. And the way the compiler resolves this is by looking at the parameters. So if you pass it a parameter with a new balance, it will use this function. If you pass nothing, then it will use this method and return the balance. Some people prefer this method. However, it is prone to error, because if you just randomly type in balance and you aren't thinking about whether you're supposed to pass a parameter or not, you'll get the wrong function. So using get and set is more explicit. However, some people like to leave out the get and set for autocomplete. It's easier to search for the proper method with autocomplete because you're not starting every method with get or set. It's a preference that you'll determine what you'll like over time. I don't mind which way you use it at this point. Okay, so we have these three functions. Let's look at our calling routine or our test routine. So we're creating two accounts, one with a valid deposit, one with an invalid deposit, and we're going to print it out. We're going to enter another deposit for the first account, and we're going to enter another deposit for the second account, and that's going to require user input. So these are straightforward. There's nothing new except for the print statements. This is a formatted print. It will print a string. It will print the $sign. And this %.2f is a special token sequence. So it doesn't actually print this out. It will print out a floating point value with 2 decimal places. And these special tokens always start with a % or a backslash. And just recall the \n is a line feed. So the %2f will print out a floating point, and we get that floating point value from account1.getBalance, which is the method we created. Okay, let's just run this. And we're going to run Java application. So let's add $25.75 to the first one, and it's added that. Notice that with the invalid account creation of -$7.53 does not work, and it just sets it to $0. Let's enter our amount for the second account, and we'll add $34.62. And that's all this application does. Recall that I don't like doing repetitive code. It's better to use methods to handle repetitive code. So let's add this to the class. And we're going to want to have an identifier. Let's copy this and paste it. And all we want to do is call getBalance. We don't need to have the object reference because this is a class. It only works on one object, and this works on the current object. And we have to use the identifier. So identifier is after account, so we'll put %s. This is the first parameter. This is the second parameter. So we'll put ident before getBalance. We can't have a space in an identifier. Okay, now we can just clean this up, and we'll just go account1.print balance, and we just add the 1. And account2 will print balance. Now we can cut and paste this without any fear of doing incorrect code. We'll save it and we'll run it. And notice we had errors here. That's because this class wasn't saved, so it didn't add it to its auto compile. Now that we've saved it, the errors have gone away. Now we can run this, and we'll just do the same thing, $25.75, $34.62, and everything works. And this code is much cleaner and easier to look at, except for this and this. And I will leave it as an exercise for you to see if you can do this yourself. Instead of credit with passing a parameter, you can just have credit do all this. And before we leave this lesson, notice this class doesn't have a main. It's a strict class. If we try to run it, there is no option to run application. That's because there's no main. That's why we created the test class. And if we look at the test class, we have Java application as an option. So if you're unable to run your class, it's because you don't have a main or you don't have a test class. And that completes this lesson.